Hello everyone and welcome to this workshop. My name is Tutu Daniela and today we're going to learn how to interact with the MultiversX blockchain using JavaScript. We're going to create, sign and broadcast transaction using controllers and factories. We're going to query the state of the account balance or the contract state, and we're going to do all this via three simple CLI applications. For this workshop, we only need the SDK core, sdk-js, because since V13, the SDK wallet and the SDK network provider were included into SDK core. Just a short note, this isn't the only SDK that we have on TypeScript. If you are building microservices, we also have one for Nest.js, and if you are building dApps, you can check the one for dApps. Another thing, it's even though it is written in TypeScript, for this tutorial we're going to use simple JavaScript. Okay, with the last version, the V14, we finished the standardization, so now the specs are finalized and you can check them. They are language agnostic. We also implement the specs on Python, so now the JavaScript and Python SDK, they are consistent, and you can check the cookbooks for the JavaScript and Python following the last two QRs. With this last final release, we also introduce entry points, and they are really, like you will see, we're going to use them, and they are so easy. It is so easy now to create transaction and broadcast them. So now let's have a quick look over the three simple CLI applications that we're going to build. The first one is called transfer. We're going to create, sign and broadcast EGLD and ESDT transfer. We're going to query the balance of an account to see the EGLD and ESDT of that account. For the second one, the other.js, we're going to deploy a contract that's called other, and we're going to interact with it without using the API. And the third one, it will be a bit more complex. We're going to play with the lottery contract, and we're going to interact using the API to see how easy it's to parse the output. Now, let's get started, because it's much easier and fun when we look over the code. First of all, I want to look over a shared file that we added to actually gather all the common functionality. It's not big, it's really small. In the constructor, we create the devnet entry point. So we're going to use the devnet for this tutorial, and the provider we're going to use, we're going to create via the entry point, and it will be the API provider. If we want to have the proxy provider, we can pass the kind here and say proxy, and it will use the proxy provider. Okay, then we add the load account. We're going to use the account to actually sign the transaction. You can verify the transaction, verify the message, and verify the message signature, sign messages. We added this on V14, and it has a bit more functionality. You can check them afterwards. For this, we want to get the path of the wallet that we have, the JSON for that wallet, and we're going to read it. We're going to ask the password from the client input, create the signer, and pass the secret key to the account and return the account. Then we have another function, another class. It's called contract app-based. It extends the app-base. This class, we're going to use it for the last two apps, the other and the lottery. Here I added two simple functions, the load contract code, where we pass the bytecode, the path for the contract bytecode, and the load contract API, where we pass the API path. The API path, it's just a short note, it's actually a JSON file that contains the contract interface, including the endpoints, the arguments, the return types, and now using the sdk-js, you can interact with the contract, either if you have the API or not. Then we return the API. Okay, now let's go to the first application, the transfer application. Let's check. In order to do fast the code, I prepared these commands, and we have these snippet files where I have all the commands, because I also have the addresses that we're going to use the paths to those JSON file, and the tokens that we're going to use to transfer and play with them. So for transfer, for transfer EGLD, we need the receiver address, the amount we want to transfer. Just pay attention, it needs to be in atomic units, and the path to the wallet. And that's all. Now let's look over the method to see how simply it is to just create a transaction. We load the account and we prepare it to sign the transaction and just use it further. We get the sender nonce. Every time when we build a transaction, we need to make sure we have the right nonce. If not, the transaction won't pass. We prepare the receiver address, we get the amount, then we create the transfer controller. So now we have transfer controller, we have a smart contract controller, delegation manager controller, and we have different controllers that will help us work. Then we create the transaction. So when you're using controllers, you create and sign the transaction. When you're using the factory, we only create the transaction. We get a transaction is ready to be sent. We already have the signature and the nonce set, and we send the transaction. We get the transaction hash and we will see it in the Explorer. So let's check. It's transfer EGLD. Yeah, it's not the correct password. Again. Now it's the correct one. Sorry for the delay. As you can see, 01 e-gold from Alice to Grace. Perfect, it's successful. Now let's see how we transfer EGLD using the factory. When you're building dApp, you're going to need to use the factories to build the transaction and the controller only to query the contract or do different queries. Again, using the factory, we load the account. We get the sender address, because for the factory we don't send the account because we don't have the account. We just we will send the sender address. We get the nonce using the entry point. We get the receiver address and the amount. Then using the entry point, we create the transaction transfer factory. Then we build the transaction. Like I said, it's just the body of the transaction. We need to set the nonce, the right nonce, and the signature. In order to sign the transaction, we're going to use the account. Then we pass the transaction. Let's check now if it's working. And if I put the right password, it worked this time. Like I said, 01 e-gold, again from Alice to Grace. Okay, let's move further. Let's see how we transfer ESDT. It's really similar. Like I said, we prepare the load account, we get the nonce, we prepare the receiver address, and we get the amount that we want to send. Then we need to get to the token that we want to send. For that token, we need to get the token identifier and token nonce. For that, we are using token computer. So token computer help us a lot with extracting nonce, extracting identifier, and checking what type of token is that one. Then we create the token from token identifier and token nonce, and we build the token transfer that we want to send. With the controller, with the entry point, we create the transfer controllers, and we call the method create transaction for ESDT transfer. That here we send the account, the sender nonce, the receiver address, and we pass the token transfer. Here I have a new line, the token transfer. We send the transaction, and let's see if this is working. Transfer ESDT. Again, let's see if we send some chocolate. You see again 01 chocolate from Alice to Grace, and it worked. Again, I want to show you how easy to do it using the factory. The we get the account, we prepare the sender address, we get the nonce using the entry point, we prepare the receiver address, we prepare the amount that we want to send, and again we use the token computer to extract the identifier and nonce. We build the token and the transfer, and then we create the token, the transfer transaction factory. For this one we need the sender address and then receiver address and token transfer. We can send multiple tokens now, but for this the purpose of this tutorial I only used one. We need to set the nonce, sign the transaction, and that's all. Like I show you, it's almost the same thing, so now it's so easy to do it. Okay, let's see if it worked. Yeah, so Grace is happy because it receives another chocolate, but not a chocolate, just a small piece. Okay, and like I said, for this tutorial we have the get balance one, because I want to show you how easy it is now to also do queries for the API. For this one we want to get the account in order to show the balance of the EGLD. Then we want to get the fungible tokens of the account and the non-fungible tokens of the account. For this, like, the input parameter is the address of the account we want to query. Let's see, I think it's get balances. Okay, and as you can see, we have the EGLD balance, the fungible tokens, and how much it has, but we don't have any SFTs, meta SFT. We query the Grace account. Okay, so this was the first application. It was the transfer one to show you how easy it is now to interact and transfer values, EGLD and ESDT. Let's move to the second one. The other application, this one is a bit more interesting because we interact with the contract, and we're going to see how easy it is to deploy a contract and after that interact with it. Let's look again at the input parameter. For the deploy command, we have the initial value and the path to the wallet, and that's all. Let's look over the method. So again, we load the account, we prepare the sender nonce via the entry point, and here we need to load the contract code because we want to deploy the contract code. For this one, we're going to use the smart contract controller. Like I said, we have different controllers now for each type of operation that we implemented. Then we prepare the deploy transaction with the specific function, create transaction for deploy. We need to send the account in order to sign the transaction, and the sender nonce in order to be able to set the correct nonce. Then we send the transaction, and here we also want to see the output, because as I said, we also can parse the output. For this we need to await for the transaction to be completed, and this method, it already parsed the response, and you will see it will give us the address of the newly created account. So we are at the header. Let's see, deploy the password, if I put it correctly. Great, let's check here. You see it was done 9 seconds ago. Now I need to get this and put it in the snippet in order to interact with it. Great, I need to load again the snippets. Because I changed them, and let's go to the header. So when we deploy it with value 1. Now we want to add value. For the input, for the add value, we have the contract address, the value we want to add, and the path to the wallet that will sign the transaction. Okay, the snippet is here. Add value, so this is the contract that we passed earlier. We want to add the value 7, and the transaction will be signed by Alice because she deployed the contract. Okay, now lottery, it's add value, run. Okay, let's see. we're going to receive okay if everything goes okay. Come on, come on, come on, come on. Maybe I didn't put the right password. Okay, you see, transaction executed with success. And now we're going to get the sum to see if it actually added the value. For this function, for this method, we only need a contract address to query the contract. Okay, so this is the method. We get the contract address, and we're going to use the controller in order to query the contract. So if you want to build transaction, you can use the factories. If you want to do the queries, you will have to use the controller. Okay, and it's simply query the contract address and the function we need to call. Okay, adder get sum, and the sum is 8. Like I said, you saw many times this warning. In order to get rid of it, you need to pass your client name to the entry point when you create it, so that we want to see who is using our application. So it's really easy to get rid of it if you want. It's just a warning. Okay, so this was the second application, the adder one, and for me it looks like it's really easy now to interact with the contract, because it's the same functionality, and it's much cleaner to interact with them. But this was a small contract, it was a short one. Let's see now a bit another one that's a bit more complex, and we're going to use the lottery and play a bit with it. Hopefully I will be able to explain and actually call the methods while the lottery is still working. But what I think I'm going to do, I'm going to work through the first methods, show you the code, and then we're going to run them to see actually the result. So the first, like always, we need to deploy the contract. For this contract, we don't need anything. If you need to see what's the input of the contract when you deploy, you can check the API file, like I said, and check the constructor. If the constructor, the input of the controller is in, it doesn't have anything, that means you don't need to pass anything for the deployment. Okay, I won't go through the method because it's the same as the other. We use the smart contract controller. And now let's deploy the contract. Lottery deploy. Okay, password. Hopefully I did it right. Deploy the contract. Okay, great. Let's take it, put it in the snippet, save the snippets, reload. We need to reload the snippet to have the right one, and also check the contract. You see, this is it. Let's continue. So after we deploy, we need to start the lottery. The start for the lottery, it's a bit more with more parameters. As you can see, we need to have the lottery name, the token identifier that we want to pay for it, the token price, how many tickets to have, the deadline, how many entries, how many can a user buy at once, the price distribution, if we have a white list, or the burn percentage. So when we prepare the lottery, we have here the arguments we want to pass. So I want the contract, the name of the lottery, the token we'll use to pay, the amount, how much a ticket will cost, and the wallet that we will use to start the lottery. Yeah, so, and also because I was looking at the buy, also the duration. So name, token, price, and duration. That's all. Because of this, we get all the input parameters. And for the arguments, because we create a smart contract controller, and when we create transaction for execute, we pass the lottery name, token identifier, price. We don't pass anything for the max entries per user. We pass the deadline, and we are not interested in all the other parameters. If you want, you can just add them. Then we send the transaction, and we're going to wait for the transaction to be completed. So this is the start lottery. Let's go over the get lottery info to see again how it is to query, because we already look over. So to get lottery info, we only need a contract because we know the name, and the not lottery name. So we get the contract, prepare the contract address, we load the ABI, we get the lottery name, and we create the smart contract controller. Here we pass the ABI because, as I said, we need the ABI for this one, we want to use the ABI. And for the query response, smart contract controller query, we pass the address, and we give the function that we want to call and the arguments. The only one is the lottery name. And that's all. The response is already parsed into the object that we want. Some other methods that we will use is the buy ticket. So we have buy ticket, and buy ticket is using factory because I want to show you how easy to do using the factory. So for buy ticket, we will have the contract, the name of the token we're going to send, the amount, and the wallet path. And it's the same for the one using factory because it's the same method, only a different approach. Here we prepare the input parameters, we load the account, we get the nonce, we get the contract address, we load the ABI, we use the token computer to actually get the token that we want to pay with, and we create the token transfer. We use the entry point to create the controller, and we pass the ABI, and we create and sign the transaction using the controller. As you see, we pass the account, the sender nonce, the contract address, gas limit, name of the function, input parameter. We just pass it because we don't need to encode it because we have the ABI and the code knows how to encode it, and we pass the token transfer. This method will be actually composed of two transactions in a transaction because it will be a transfer for the token that you want to pay and the buy ticket. Then we send the transaction and we wait for the completed result that will return us the output that's already parsed. Okay, for the buy tickets using factory. For this one, it's the same for the input, but I wanted to show you something a bit different. So if we are using the factory, that means we don't have already the parsing stuff included. So we need to create a parser. For the parser, again, we can send the ABI so he knows how to parse the output. And I said, let's try something different and use directly the transaction factory, not via the entry point, just to show you that's easy to do also without depending on the entry point. So I created a new transaction factory, I passed the API, and I passed the config. For the config, I was only interested in the chain because we said we want to do it on development. Then we create the transaction for execute. We pass the sender address, contract address, gas limit, buy ticket, lottery name, and token transfer, the same as when using the controller. Now, because of the factory, we need to pass the transaction, set the transaction nonce. We need to sign the transaction using the account, and then we send the transaction that will give us back the transaction hash. But in order to parse it, we need the actual transaction. So we are using again the entry point to get the transaction, and that transaction we pass it to the parser. Parse execute, pass the transaction, and we set the name of the function we want to parse. This will help us parse the exact response. Okay, and we reach the final method called determine winner. Determine winner, it's received again the contract, the name, and the wallet that will sign the transaction. We get the account, we get the sender nonce from the network using the entry point. We set the nonce, we get the contract address, we load the ABI, we get a lottery name. Then we create a smart contract controller, we pass the ABI, and we build the transaction, determine winner. For the output, and then send transaction, we await completed executed from controller. That means we're going to receive directly the output. For this one, you will see determine winner. The response is empty. but we're going to check to see the exact we're going to check to see the the last transaction what it actually did, because determine winner, it already sent the money to the winner. Okay, now let's do it. So let's do the whole flow. Like I said, we deployed the lottery. Now we need to start the lottery. Oh, it's lottery start. Password. Okay, return code was okay, and lottery get info to see. You see it's Alice, the token 1, the price 800, tickets left, and the deadline. Okay, now let's buy a ticket with Grace. We buy a ticket with Grace. Buy a ticket with Grace is done via the controller. Perfect. We buy a ticket with Alice using the factory. You see? And now let's actually check, because we need to let a bit time to let's buy one more ticket with Alice using the controller. Hopefully I put the right password. It's okay. Great. So let's look now. So this is the start transaction. As I said, at the start, these are the null values that we passed here. Then we did a buy ticket with Grace, pen 01. We did a buy ticket with Alice using the factory, and then we did a buy ticket with Alice again using the controller. Let's see if we can still get the lottery info. All is done. Yeah, as you can see, the price pool is 3. We bought 3 tickets. We have 797 left. The price distribution, and we need to wait a bit more in order for the lottery to be done, and then we're going to query the lottery. Okay, so as I said, this is everything that you now need to do in order to interact with the smart contract. Isn't it really easy? For me it's really easy, because I worked with smart contracts since the beginning, and it was much harder to interact with them because we didn't have anything, we didn't have all of this prepared. Okay, I don't know how much time I put for the lottery to take. 100 milliseconds, 10 seconds. Okay, and now let's do lottery determine winner. It was okay, and let's check the transaction. You see, determine winner, and the winner was, oh, the winner was Grace. Even though, yeah, so for the contract to Grace, even though Alice bought 2 tickets, the winner was Grace. That's nice. Okay, so this was the second app. So this is the lottery one. Yeah, so we went through, let's see what we covered today. Let's see what we covered today. Okay, so we did 2 simple CLI applications using SDK-js. What we learned? We learned how to interact with the network via entry points. We created and broadcasted transactions with both controllers and factories, we deploy and interact with the contracts, and we query the account state and the contract state. What you can check after this? As I said, now we are building controllers and factories for different parts, different functionalities. So we have a multi-sig controller, if you want to go and check that one. We have a governance controller and factory delegation controller, token management controller and factory, and not just this one. So you can go and check. Thank you for your time. I hope it was really helpful for you, and don't forget to check the existing documentation. We also updated the cookbooks to be easier to follow, and have fun building. Thank you. Bye bye.